For our video today, we're going to take a look at multiplying decimals. So the first thing we're going to look at is going to be the mastery that you did for multiplying decimals. The first question says, a soup recipe calls for 2 2/2500 cups of vegetables. Ethan wants to make 5 batches of soup. How many cups of vegetables does he need? So if we're looking at, if he needs to make 5 whole batches of soup, and each one has 2 2/2500 cups, that would be a hint that we need to multiply these together to figure out how much total. So we're going to take our 2 2/2500 and multiply it by 5. If I look at the numbers that I'm multiplying together, I should be able to use some estimation in my head to figure out where would be a good ballpark of what my answer should be close to. I know that 2 2/2500 is close to 2. And we have a whole number 5, so I'll keep that the same. These are easy numbers that I can multiply together in my head. When I multiply them, I get 10, so I know my answer should be close to 10. So I'm going to be looking for that when I'm totally done. I'm going to go ahead and multiply, starting with my 5 times 5, which gives me 25. 5 times 2 gives me 10, plus 2 gives me 12. 5 times 2 gives me 10, plus 1 gives me 11. So we've done a lot of work with comparing decimals and adding and subtracting decimals, and we've talked about lining up your decimals and dropping them into your answer. But that's not going to work when we're multiplying. When we're multiplying, we need to look at how many digits we have all together in the numbers that we're multiplying to the right of the decimal. So we have a 2, which is to the left of the decimal, so that's a no. We have a 2 in the tenths place, which is to the right of the decimal. A 5 in the hundredths place, which is to the right of the decimal. So far we have 2 digits to the right of the decimal. Now let's look at our 5. Our 5 is a whole number, which means it's in the ones place. So our decimal, we have a decimal for every single number, even if it's not written. The decimal for our 5 goes to the right of the ones place. So since our 5 is in the ones place, it is not to the right of the decimal, so we're not going to include it. We have 2 digits all together to the right of the decimal, so when we move our decimal in our answer, we're going to start at the right-hand side and move 2 places to the left. So our answer would be 11 2/2500 cups of vegetables. So let's look back at the estimate that we did previously. We said that 2 times 5 equaled 10. We said that was a good estimate we could do in our head, and our answer is 11 2/2500, which I would say is very close in the ballpark of what our estimate said that it should be. Okay, let's take a look at the next one. Number 2 says, what is the product of each expression? Remember, when we see the word product, that means the answer to a multiplication problem. An expression is just going to be numbers that are multiplied, added, subtracted, or divided together, but there isn't an equal sign that goes with them. It says drag each product into the box on the right column to match the expression in the left column. So here they give you 5 options. You need to drag whichever one equals. This is when estimating can absolutely come in handy. This first one, we have 41 6/10 times 2 3/10. If I estimate in my head, I could say 41 6/10 is very close to 40, and 2 3/10 is very close to 2. When I multiply 40 times 2, that should give me a hint that my answer should be close to 80. When I look at my answer choices, I have 9 568 thousandths, I have 95 68 hundredths, I have 956 8/10, and 9,568 10,000ths, and then 9,568. The only answer that is remotely close to 80 is going to be my 95 68 hundredths. Even though I'm thinking that that's going to be the answer, I'm still going to multiply these out just to double check. So if I write down my numbers, I have 41 6/10 and 2 3/10. So let's go ahead and multiply those. I'm going to start with my 3. 3 times 6 gives me 18. 3 times 1 gives me 3, plus 1 equals 4. 3 times 4 gives me 12. There's nowhere else to regroup, so I'm going to put my whole 12 down. I've already used this 1, so I'm going to cross it out. Now I'm moving into a larger place value. I'm moving to the ones place. So because this 2 isn't worth the same tenth that my 3 was worth, I need to put a placeholder 0 here. Now I can go ahead and multiply 2 times 6, which is 12. 2 times 1 is 2, plus 1 is 3, and 2 times 4 is 8. I'm going to go ahead and add these together. 8 plus 0 is 8, 4 plus 2 is 6, 2 plus 3 is 5, and 1 plus 8 is 9. Okay, if at any point I'm going too quick, or if you want to stop the video and do the problem yourself and then check it as I go through it, feel free to do so. If we look at our numbers and we want to figure out how many digits we have to the right of our decimal point, I'm going to look at my 4 in the tens place. That's not to the right of it. My 1 in the ones place, not to the right of it. My 6 in the tens place is to the right of the decimal. My 2 in the ones place is not, but my 3 in the tenths place is. So this one would be one where it would be really easy to see that your decimals are lined up and just put your decimal in your answer. But we need to look at how many digits we have to the right of the decimal. In this case, we have 2. So we're going to move our decimal point from the end 2 places to the left. And our answer is going to be 95 and 68/100ths, which is what we were originally thinking, because we had our estimate of 80. So we could go ahead and write 95 and 68/100ths here, or in this case, an actual problem, we would have dragged and dropped it. Our next one says 4 and 16/100ths times 23/100ths. This one might be a little bit trickier to estimate, but if we think about our numbers, we might be able to get a good idea of what we might be looking at. This number, I would say, is close to 4. Okay, here we have a number that is less than 1. So I wouldn't even say it's even very close to 1. 2/10 is much closer to 0 than it is to 1 whole. So maybe we can't round this to the closest whole number other than, we could round it to 0. But we are able to think reasonably and say, I know that anytime I multiply a whole number times something that is not a whole number, that is less than 1, I know that my answer has to get smaller. Anytime we multiply something by something that's less than 1, your answer will get smaller. So if I look at my possible answer choices, I know that my answer has to be smaller than 4. I'm not even getting one whole group of 4, I'm getting less than one group of 4. So if I look at my answer choices, this is 9 and part of a decimal, this is 95 and part of a number, 956 and part of a number. The only one of these that is actually less than 4 is 9,568 10,000. So I'm guessing that that's going to be my answer before I even do the problem. But let's go ahead and check it and see what we get. So we have 4 and 16/100ths, and we have 23/100ths. You may realize these are the exact same digits as your first one, only your decimal points are in the different place. So you could go ahead and multiply all this out, but we know that we're going to end up with the same digits as we did in our first problem. So to save time, I'm going to go ahead and write those out. This time I have my 4 in the ones place, which is not to the right of the decimal, but my 1 and my 6 are in the tenths and hundredths place, which are to the right of the decimal. My 2 and my 3 are also in the tenths and hundredths place, so they are also to the right of the decimal. If I move my decimal from the right 1, 2, 3, 4 places, we're going to get 9,568 thousandths, which is exactly what we thought, since we had 4 times a number that was less than 1. Okay, so we could go ahead and write our answer in. If we take a look at our last option, we have a number that's very close to 4 and a number that is very close to 2. And when I multiply those together, I'm going to get 8. So if I look at my answer choices that are close to 8, the only one that's sticking out to me that's even remotely close to 8 is going to be this 9 and 568 thousandths. If I take a look at multiplying this, again, I'm not going to multiply the whole thing out again. We're just going to take a look at where our decimal should go in our answer. We know we're going to end up with 9,568, and then let's think about where the decimal should go. We have a 4 in the ones place, so that's not to the right of the decimal, but our 1 and our 6 are to the right of the decimal. Our 2 in the ones place is not to the right of the decimal, but our 3 in the tenths place is. So altogether we have 1, 2, 3 digits to the right of the decimal. When we move our decimal over, we're going to end up with 9 and 568 thousandths, which is exactly what we were thinking when we estimated. So it's really important that we think about our estimation because we can almost automatically come up with the answer when they're given some choices before we even actually do any multiplication. It's really easy to put your decimal in the wrong place, so by thinking about what your answer should reasonably be, you're going to get a much easier idea if you're on the right track. Okay, let's take a look at our next question. It says Wendy has 1 5/10 packages of crackers. Each full package weighs 3 67/100 ounces. Wendy wants to know how many ounces of crackers she has. She draws this area model to find partial products. So what this sentence is telling you, this is an area model. You're finding the amount of space inside this entire rectangle. And by partial products, they're saying, remember, a product is the answer to a multiplication problem, and partial means you're finding a part of it or a piece of it. So you're going to find a piece of the answer in each one of these boxes, and then we're going to add them together to find the whole answer. It says complete the model by placing the numbers in the correct positions. Note that the white boxes in the model are for the answers and do not represent an unshaded portion. So they're just letting you know, put your answers in the white boxes. So the way that we do this problem is we take a look at the numbers we have on the left-hand side. This is telling you 1 5/10. So all together, this number is 1 5/10. This here, if we put these parts of the number together, we would have 3 6/10 and 700. So this would be your 3 67/100 that they just broke into their values for each place value. Let's take a look at how we would multiply it. What we're going to do is we're going to take a look at where each box has a number on the left-hand side and a number on top that would intersect and meet in that white box. In this case, this one would be 1 times 3. 1 times 3, which would equal 3. Okay, down here, we would have 5/10 and 3 that would be intersecting. Okay, let's think about what that should look like. 5/10 times 3. Well, I know that 5 times 3 would give me 15. And then how many digits do we have to the right of the decimal? My 5 is to the right of the decimal. My 3 is a whole number, so it's in the ones place. So the decimal is actually to the right of it. So that is not to the right of the decimal. So I need to move my digit one place to the left, or move my decimal one place to the left. So this would equal 1 5/10. Here, we would have 1 coming over times 6/10. Well, I know that anything times 1 is going to remain the same, so 6/10 is going to be our answer here. Down below, we would have 5/10 multiplied by 6/10. Okay, let's go ahead and write that out. I know that 5 times 6 would give me 30. And both of these digits are in the tenths place, so they're both to the right of the decimal, so my decimal would actually move to the left of my 3. So my answer would either be 3/10 or 30 hundredths, however you want to write it. In this box, we would have 1 times 7 hundredths. Again, anything times 1 is going to stay the same. And in this box, we would have 5/10 times 7 hundredths. Okay, so let's write that one out. I know that 5 times 7 would give me 35. And all together, I have 1, 2, 3 digits to the right of the decimal. All of these, even the 0, counts as being to the right of the decimal. So we need to move 1, 2, 3 places to the left. But I need to remember that I have to hold this place value. My 3 has to be in the hundreds place, and my 5 has to be in the thousands place. So I'm going to put a 0 here to hold that place value. So our answer here would be 35 thousandths. Now that we have all these partial answers, we need to go ahead and add them together. So let's make sure that we line up our decimals carefully, line up our place values. So my 3 is in the ones place. We'll give it some zeros. My 6 is in the tenths place. My 7 is in the hundredths place. My 1 5/10, 30 hundredths, and 35 thousandths. I always like to fill in the missing place values with zeros so that I hold their spot. Okay, all these zeros plus 5 should give me 5. 7 plus 3 would give me 10, so I will regroup my 1. 1 plus 6 is 7, plus 5 is 12, plus 3 is 15. Regroup my 1. 1 plus 1 is 2, plus 3 would give me 5. And we know that when we're adding up our numbers that have decimals in them, we need to go ahead and just drop our decimal point down into our answer and line up all of our place values. Okay, let's go ahead and take a look at a question that has a model with it. It says Clara has 2 rolls of ribbon and each roll is 3 29/100 yards on it. She draws this model to determine the amount of ribbon that she has in all. You need to decide if these statements are true or false. So let's go ahead and look at a few of them. We need to decide if this model is showing that the product of 3 29/100 and 2 is greater than 6. So what they're asking you here is you could actually multiply 3 29/100 times 2, but if we take a look at our model, we know that each one of these grids that's completely shaded in is equal to 1 whole. So altogether I have 1, 2, 3, 4, 5, 6 whole grids shaded in. And then we actually have some extra on both of these. So I know automatically without even finding the answer that yes, my answer is greater than 6. So that one would be true. The second one says the model shows the partial products of 3 29/100 times 2 are 6, 4, and 18. So let's be careful here because they're showing you whole numbers here. So at anywhere on this model, do we see that they're showing us 18 as a whole number? That would be 18 whole grids shaded in. So this one I know without looking at anything else is going to be false. Clara has at least 8 yards of ribbon in all. So that would mean that we would have to have 8 whole grids, which we do, but it would be 8 whole grids completely shaded in. Well, we have 6 of them that are completely shaded in and part of the 7th and 8th grid, but altogether we do not have 8 whole grids shaded in, so this one would be false. The product of 3 29/100 and 2 is equivalent to 6 plus 4/10 plus 18/100. So what they're showing you here is 6 whole grids, 1, 2, 3, 4, 5, 6. The 4/10, remember 1 entire row is worth 1/10, which you have 1, 2, 3, 4 of those, so that's good. And 18/100, which would be your last row of tenths that's not completely shaded in. So there's 9/100 here and 9/100 here, which together would equal 18/100. So all of these are correct. This one would be true. The final product of 3 29/100 and 2, Clara can find is 6 times 4/10 times 18/100. Well, we just figured out that it actually is all of these options added together. So we know that we can't multiply them together and get the same answer. That would be false. The product of 3 29/100 and 2 is 6 58/100. Well, we just said we have 6 whole grids. And do we have 58/100? Do I have 5 whole tenths shaded in? Yes, and then 8 remaining 100 squares. So that one would actually be true. This you could also check by actually multiplying 3 29/100 times 2.